Hello friends, welcome to Suresh Aggarwal's Mathematics Shortcuts. Yet another amazing video and yet another video in which I'll be taking up a topic which troubles so many students. Division of numbers. Can you divide numbers mentally? Yes, of course you can if you have some basic knowledge of some of the very useful tips and tricks. So it's a very comprehensive video in which I'll be telling you 10 different short tricks through which you can divide numbers very quickly. There are some basics, and after watching the entire video, the question written here 65238 divided by 13, you would be able to do this mentally without having to count 13 times table, right? So you got to watch the entire video, and if you have not subscribed the channel by till now, you got to subscribe it. Just click the subscribe button and do share this video with all your friends, and if you want to get the notifications of all future uploads, you need to click the bell icon also along with subscribing the channel. So let's get on with the video and learn the first basic thing, which is doubling and halving. So we should be really quick in doubling the numbers and halving the numbers. That means taking the half of any number. That is the basic thing we should know for dividing numbers very quickly. So I'll demonstrate by taking the example of division or dividing by 2, 4, 8. See, these are multiples of 2, right? 2, 4, 8. Okay. So I'll take only these three, and then you can generalize it on some other numbers also. Let's get on with it and take the first example, 79 divided by 2. See, whenever you have an odd number and you want to divide the number by 2, you don't have to think about the decimals. Just take one less than this. So in the mind, just think 78, not 79. So half of 78 is easier because it is an even number. So that's 39, right? And just put 0.5, you will have your answer for division by 2. When the number is even, it's all the more easier, like 1696. Suppose this is a number and I need to divide this by 2. Then halving in the mind, that is what works for us. How do you speak this number in your mind? Do you call this as 1696? I think we are creating a problem for ourselves if we speak like this in our mind. So we have to think about this number as 1696. So this is mental maths now. You have to think about the number 1696 as 1696. Now halving will be all the more easier because taking the half of 1600 is pretty easy, that is 800, and taking the half of 96 is easy, it's a 2-digit number, so 48, and therefore 848 becomes the half of 1696, or when you divide 1696 by 2, you are going to get 848. Likewise, if you have to divide numbers by 4, suppose I take an example of 2160, an easy one first up, and I have to divide this by 4. So I know that division by 4 is repeated halving. That means you have to take the half of this number 2 times. Dividing a number 2 times by 2 or dividing it by 4 means the same. And so half of this number, how do you speak that in your mind now? It's not 2160. It's 2160. So 2000 becomes 1000 and 160 becomes 80. So 080. So 1080 is the half of 2160, and further if you take half of this also, 1000 is 500 and 80 is 40, and there we go, the division problem is solved. 2160 divided by 4 is 540. Next, if we have an odd number, suppose you have a number like 775 and I need to divide that by 4. Again, I told you how to divide the number by 2. So you have to consider this as 774 in the mind. 774. See, 74 is 37. and 700 is 350. So 350 and 37 is 387. So that's how you take the half of numbers. So this becomes 387, and then you have to put 0.5 also because it's an odd number, and finally you have to take the half of this number also. So what do you have to do is you have to either divide it mentally by 2, or you can borrow 1 from here, like 1.5. This 1.5 will become 0.75 when you take the half, and 386, half of 386 is 380 is 190, and then 3, 193. And now pick up the calculators and check. 775 divided by 4 is that 193.75, and you will be surprised that the answer is not wrong. Let's have a question where we have to divide a number by 8. Let's take an even number first, 8, 6, 7, 4, and divide that by 8. So repeated halving, I am just taking up repeated halving as of now to divide numbers by 2, 4, 8. Repeated halving means 8, 6, 4, 8, right? So 4, 3 and 74 is 37, right? So this is division by 2. Now again one more time you have to halve this number. So 2, 1, and then 13 means 6 and 17 means 8.5. And one more time because it is divided by 8. So 2 times 2 times 2, right? So 3 times halving. So 1084.25. There we go. 1084.25 is the quotient. If the number is perfectly divisible by 8, it is very easy. Just like 5336 divided by 8. Now you got to try this, okay? So I am giving this as a DIY question, do it yourself question. You can try this and post your comment here in the comment box. Did you get it right, and how much time you took to crack this question? Let's move on to the next trick. Here we have division by 5, 20 and 50. These are all special numbers, right? So let's see how we divide numbers by 5, 20 and 50. The first example I am going to take up is 93 divided by 5. Now just understand, 93 upon 5. Division by 5 is not easy, but if you convert this 5 to a base number like 10, so you just have to double this and divide the result by 10, because this will become 90 is 180 and 3 is 6. See, doubling helps us here. 93, 186, and divide by 10, you get your answer. 18.6 is the quotient. Likewise, suppose you have a question where I have to divide 3147 by 5. Okay, so when I have to do this, what will I do? I will take the double of this number and divide by 10. So double of this is 6, 1 becomes 2, and 47 becomes 94, and divided by 10. See, doubling helps us here. And now division by 10 is pretty easy. 629.4. That is the quotient when you divide 3147 by 5. Now coming to division by 20. Suppose you have 464 and you want to divide this by 20. Now division by 20 is actually halving and dividing by 10, because 20 is 2 times 10, right? So if I have to do 464 divided by 20, I will do 2 times 10. So I just have to take the half first. So what is the half of 464? Very easy. 2, 3, 2. And when you divide it by 10, you get your answer. 23.2 is the quotient. Now you can check using the calculator. Likewise, if you have big numbers, suppose I'll take little bit of a big number like 896 divided by 20. Now you know what to do, right? You have to just take the half of the number, half of this, and divide it by 10. So should I leave it as a DIY? I think you can do that. So this is the second question which you need to do, and tell me in the comments how much time did you take to solve this division problem. Okay. Now coming on to the division by 50. Let's take 3583 division by 50. Now see, understand and do, and I think it will work for you. Any number divided by 50 can be converted to 100, right? 50 can be converted to 100. just by doubling again. So you have to be very good in doubling of numbers. Just like halving worked for us when we divided numbers by 2, 4 and 8. Now doubling is helping us. And that is why I was stressing so much on doubling and halving of numbers. So what is the double here? See, 3500 is 7000, right? 83 is 166. So 166. See, how do you double the numbers in the mind? And then divide by 100, which gives us 71.66. I don't think division by 100 should be a problem, right? So 71.66 is the quotient. Let's take a big number now. 56149, and I need to divide this by 50. So what did I tell you? You have to double it, right? Doubling of this is actually multiplication by 2. So either you can do it directly or you can do it in mind. So when you multiply this by 2, you get 1122, and then 49 becomes 98, and then divided by 100. So what will be your answer? Just put the decimal. 1122.98 will be the quotient. Now you can check using the calculator. Likewise, there are so many tricks, and there are some special divisors which can be handled so easily. Just like division by 9, very very interesting, and very, what do you call, you tend to develop more interest, when you do such methods. Let's see division by 9. So suppose you have to divide 85 by 9. It's very important for junior students. If you learn these skills right at the school level, obviously it helps in developing positive mathematical aptitude. So when you have to divide a number by 9, just like you do in a division problem, I do that the same thing. So this is the divisor 9. Now put a horizontal line, bring down the first digit 8 and add this digit to the next digit here. Okay, so this becomes 13. Now 13 is more than 9, right? So I can subtract a 9 from here. The first multiple of 9 I am subtracting from here, and therefore I have to increase this by 1. So that's it. What do we get? 9 here, and 13 minus 9, 4 here, and surprisingly this 9 is the quotient and this 4 is the remainder. So for the first question it might look little awkward, but when you practice this, like taking 20 such questions, 3 digit, 4 digit numbers, you will find this really interesting. Let's do one more. Let's do 678, and I need to divide that by 9. So watch now. There is a slight change because it's a 3 digit number. So I am going to divide this by 9 now. The first step I told you is put the horizontal line, bring down the first digit 6, add it to the next digit. 7 plus 6 is 13, and now we have another digit, right? So 13 is to be added to the next digit here, and 13 plus 8 becomes 21. So we get 3 numbers now. And now look at the last number 21. So how many multiples of 9 can I subtract from 21? It is 2 multiples, right? 9 2s are 18. So I'll subtract 18 from here. And what will happen to 13 now? 13, because I subtracted 2 multiples, so this will get increased by 2, thereby giving me some new numbers under the horizontal line. This is 6, this is 15, and this is 3. Now just retain the single digit 3, retain 5 from here and carry forward the 1. So 6 plus 1, 7, and now you need to check whether the last digit is the remainder and this one 75 is the quotient. You can pick up the calculators and check whether the answer is correct or not. Likewise, you can do it for 4 digit numbers also. 7093 divided by 9. Let's try this. So I am going to do the same thing, 7093, and I am going to divide this by 9. So what did I tell you? Put a horizontal line, bring down the 7. Now this 7 is to be added here. So 0 plus 7 is 7 again, and then 7 is to be added here, which gives me 9 plus 7 as 16, and 16 to be added here, which gives me 19. So I got 4 different numbers: 7, 7, 16, 19. Let's subtract the multiples from the last number. So 9 2s are 18. So I can subtract 18 from here. And how many multiples I subtracted? 2. So I'll add 2 to the previous number. So let's see what are the numbers we obtain now. This is 1, this is 18, this is 7, and this is 7. Now once you do this step, you just have to retain the unit digits of the answer and carry forward the tens digit. So 1, 8, 1 carried means 8 again, and 7. Now the last digit becomes the remainder, and remaining thing 788 becomes the quotient. So 7093 divided by 9 is 788 quotient and 1 remainder. Isn't that wonderful? Some special techniques of division, but be really careful that you have to perform this division only by 9. Okay, so in mathematics nothing works for everything, and that is why you need to be very particular by which number you are dividing. Let's do division by 11 short trick. Another very interesting concept. Whenever you have a proper fraction, like suppose you have 1 upon 11, okay, just multiply the numerator 1 by 9. So this is the default number 9. You will get 9 itself, but express it as a 2-digit number 09. So your answer will be obviously 0 point because it is a proper fraction, and 09 will keep on repeating. So 09 bar. So 0.09 bar is the quotient. So you can do 2 upon 11. So I know 2 times 9 is 18. So 0.18 bar. If I do 3 upon 11, it will be 3 9s are 27. So 27 bar, and so on. Now I think all the proper fractions can be done like this. So I'll give you a DIY. Can you tell me what will be 6 upon 11? Now this is a DIY, so you will post your comments and let me check whether you get it right or not. Now division by 11 can be done using this trick, but what about improper fractions? In improper fractions we have the numbers which in the numerator we have the greater number, right? Suppose let's take a random number 103 and I have to divide by 11. So always express the improper fraction as a mixed number first. 11 9s are 99, so 103 minus 99 is 4, so 411. Now your answer will be 9 point, and 4 upon 11, use this method. 4 times 9 is 36, so 36 is going to repeat over and over again, thereby giving you the decimal representation of 103 by 11 as 9.36 bar. Let's do 756 by 11. I think that also works. 756 by 11. So 11 6 are 66. So we have 96. 11 8s are 88, and then 8 upon 11. So what did I do? I just expressed it in terms of mixed number. So my answer is going to be 68 point something. And what is that something? 8 times 9 is 72. So 72 bar. So 68.727272. That is going to be the quotient when I divide 756 by 11. Similarly, we have rules for division by 7 also. If you divide by 7, do you know what happens? 1 upon 7 is actually 0 point. Now the double of 7 is 14, double of 14 is 28, and double of 28 is 56. Add 1 to that, 57. These are the 6 digits which are going to repeat over and over again. 0.142857 bar. Now the interesting thing is what happens in 2 upon 7. Obviously it will be 0 point, and see the wonder now. If I start division, normal division, 20 divided by 7 will give me the first term, I mean the first digit after decimal, as 7 2s are 14, 2, right? So in this 1 by 7, I'll start with 2, 2, 8, 5, 7, and then come back to 1, 4. And this will be my non-terminating decimal representation of 2 by 7. Likewise, if I have to do say 101 by 7, so I am taking numbers in hundreds, you have to first represent it as a mixed number. So that gives me 14 7s are 98, okay, 14 and 3 by 7. So what will be my answer now? 14.3, right? So 30 by 7 will give me a 4. So I'll start with 4 here. 4, 2, 8, 5, 7, 1 bar. So these 6 digits are going to repeat over and over again. If I divide 101 by 7, I'll get this on the calculator. You can check. Right? So this is the trick in which we divide numbers by 11 and then the numbers by 7. 14.428571 bar. Likewise, we can go on and extend the video to any length. Let me take one more. This is another very interesting and very important short trick in mental maths. Division by 13. So suppose you have to divide 9 by 13. Okay. Now 9 by 13, watch the method first. 9 by 13. The numerator is 9 here. Okay. So there are some steps. The first step is take the numerator and multiply it by 7. Now this is fixed. Okay. Whatever I am doing, I am putting in the square, that is a fixed operation. So you will get 63. Then in the second step, whatever you get here has to be multiplied by 11. That is also a fixed operation. So you will get 6. 6 plus 3, 9, and then 3. And then this number 693 is to be reduced by 1. Now this minus 1 is also a fixed operation. So you get 692. And finally, you know the 9's complement. I hope you know the 9's complement. Subtract all the digits from 9. 9 minus 6, 3, 9 minus 9, 0, 9 minus 2, 7. That's it. Now these are the series of operations you have to do to get the answer for this one. It's a proper fraction, so 0 point, right? And the first part is this 692 and the second part is this 307, and these 6 digits are going to repeat over and over again, giving you the decimal representation of 9 by 13. So we can do any number now. Say I'll take only one more example, 47 by 13. Let's write it as a mixed number. 13 3s are 39. So 8, right? So 8 by 13. Now I know that my answer will be 3 point something. 8 times 7 is 56. 56 times 11, 661. And 616 reduced by 1, 615. Then 615 comes here, and the 9's complement, 9 minus 6, 3, 9 minus 1, 8, and 9 minus 5, 4, 3, 8, 4, and that's it. So you can calculate like that, and there are so many different tricks, for higher numbers also. I think for this video, these 10 short tricks which I have told you should be enough, and we will take up higher numbers also in our subsequent video. Practice all these things, and I'm sure these numbers like up to 13 division is not going to trouble you anymore. So if you like the video, do share it with all your friends, and for your practice, it's all the best.